Hello everyone. In our last class, we discussed about the least distance of distinct vision. The least distance of distinct vision is 25 centimeters for a healthy person and angle of vision is 60 degrees. Okay, we discussed in our last class least distance of distinct vision is 25 centimeters and angle of vision is 60 centimeters. Then, and we discussed that these values are differ from different persons and age. Then the person to person, and by the age, the least distance of distinct vision and angle of vision is various. Right? Why it is various? Why these values are various? To know that, before we have to know the structure of eye and its functions. We have to know structure of eye and its functions. Then eye is a sense organ, very important sense organ and a sensitive one. It is a sensitive sense organ. Okay. Then we are going to discuss about then a structure and its functions. And when reflector ray is fall on our eye, we can able to see the objects. Right. Here, eye is almost all in spherical in shape. Eye is almost all in spherical in shape. Its diameter is approximately 2.3 centimeters. Okay, it is almost all spherical in shape and its diameter approximately 2.3 centimeters. And front portion of eye. Okay, front portion of eye is sharply curved. Front portion of eye is sharply curved and it is covered by the transparent protective membrane is called cornea. What it contains? Cornea, not corona, right? Cornea. The front portion is sharply curved and this sharply curved is covered with a transparent protective membrane called cornea. It is act as a window of world. Why? Because the cornea is the outermost part of eye which we can able to see. Right? This part, outermost part of eye is called cornea. It is a cornea. Right? And it allows the light to pass into the eyeball. The reflector ray which is fall on eye, which is fall on cornea, right? It allows into eyeball. Right? That's why we call it is a window to the wall. Okay. And behind the cornea, a place filled with a liquid is called aqueous humor. Right? The place filled with aqueous humor, and this humor, in this place it is filled. Okay, this place is filled with aqueous humor. It is a water like saline liquid and it helps its function is refracts the light from the cornea. Got it? Then from the cornea it can refracts it. Which one? Aqueous humor. The light is falls on cornea and it refracts from the cornea to the aqueous humor, and aqueous humor is also the light travels through the aqueous humor also. and very behind the aqueous humor, it has a muscular diaphragm. One muscular diaphragm is called ciliary muscle. Sorry, iris. Sorry, no. It is a muscular diaphragm. It's called iris. The muscular diaphragm, it is called iris, right? And behind the cornea and in between the cornea and the ciliary muscle, sorry, iris, it consists of aqueous humor. It consists of aqueous humor, right? It is a muscular diaphragm, is called iris. Iris is a colored portion which is appear in our eye. Only the colored portion is colored part in our eye is iris, right? You may find, you may observe many have different colored iris, brownish or blue, right? Such kind of eyes, you can notice that is iris. Then in our eye, only the one part contains the colored one. It has a pigment that is called iris. Got it? Right. Then iris has a small hole is called pupil. This is called what? Pupil. Small hole, it called a pupil. Okay, it appears in black in color. It appears in black in color because then light enters into the inner part of eye through the pupil only, right? A light which is fall on cornea and it refracts it through the aqueous humor and it enters into the inner part, and that light is reaches into the inner part by this pupil only. Okay, only the pupil can allow the light to pass to the inner part. Here cornea allow to pass the light towards eyeball, right? Here it center and it travel through the pupil, and the pupil's diameter is approximately 1 millimeter, right? And the pupil can able to contract and expands also, right? Then its diameter sometimes it decreases less than the 1 millimeter and sometimes it increases more than 1 millimeter, right? At what conditions? At what conditions the pupil size is increasing, pupil size is decreasing, right? When we are observing the things in low light conditions, right? In a low light conditions, the iris is makes pupil to expand. Got it? In which conditions then pupil is expands, and in low light conditions, the iris makes the pupil to expand to allow the more amount of light into our eye. Got it? In which conditions? Low light conditions, right? To form the image, to form a sharp image, we required a sufficient amount of light. When we enter into the dark places, when we enter into the dark rooms, there the intensity of light is less. In such cases, we required some sufficient amount of light. For that sake, the iris makes the pupil to expand to allow the more light into it to find the objects. Got it? Right. If we enter into the high light conditions, that means intensity of light is more. If intensity of light is more, say in summer season afternoon session, it has much light, right? In such conditions, then iris makes people to decrease its diameter, decrease its size. Got it? Why? Because that is allows the less amount of light to pass through it. Okay, what I said, we required some sufficient light. In low conditions we can't get sufficient light, so in such cases if pupil size increases, it has a chance to enter more light. In high intensity of light, in high intensity of light conditions, in such cases it has much amount of light, but we required sufficient one. In such cases, then iris makes the pupils to decrease the size, then a less amount of light is passed through it. Okay, got it? Then this can done by the iris. That is a work of iris. That is a function of iris, right? Iris is the part which is appears in colored, right? Iris consists of much pigment. So that's why it appears in different colors for a person. And here one more thing, any two persons iris is not same. Any two persons iris is not same. And this iris function is, iris consists of a small hole that is called as pupil. Pupil can allow the light to pass through the lens. Okay, and the pupil sometimes it can be expanded and sometimes it contract, right? Then when we enter into the low light conditions, in such cases the iris makes expand the pupil, and even we enter into the high light conditions, then iris makes the pupil to decrease its size. Why? Because there it has much light. And have you ever observed, and may you notice it, when you enter into the suddenly into the dark room from high light conditions, then from high light conditions to if you enter into the dark light condition, dark room, suddenly you can't see the objects properly. Why? Because then you are, before that you are in high light condition, that means intensity of light is more. In such conditions your pupil size is decreased. Then when you enter suddenly, then the pupil size is less, no? So because of that reason the appears is not that objects is not appears properly. Then it takes few seconds of time. After that, then iris can adjust the size of a pupil to observe it. When you enter into the cinema hall, right, when already cinema is playing, then when cinema is started, then all doors will close, no? And if you enter into the cinema hall, that is totally dark, then for few seconds you can't observe anything, any chairs in it, because of you entered from the then from light conditions to dull light conditions, low light conditions. Because of that reason you can't observe it. Then after 10 or 15 seconds, then your iris is adjust the size of the pupil, then it is allows the sufficient amount of light, then you can able to find the chairs and you can easy to work. Got it? This is the function of a pupil. This is a function of pupil. Just behind the iris, it consists of eye lens. It consists of eye lens. This is called eye lens. This is eye lens, right? Have you noticed what is the shape of eye lens? We have already discussed in our previous chapter. See, both the sides are convex surface, right? Both the sides are convex surface. So our eye lens is biconvex. We have in our eye, it contains the biconvex lens, convex lens. Got it? Convex lens. And the eye lens forms the image. It forms the image behind the lens. It contains one more delicate membrane is called retina. This is what? Retina. Retina. And here you have to notice the distance between eye lens and retina is 2.5 centimeters. The distance between eye lens and retina is 2.5 centimeters. And it is fixed. This distance is fixed. That means then eye lens forms the image on retina. Then this 2.5 centimeters is considered as image distance. That is considered as image distance. So V equal to 2.5 centimeters. Got it? Then retina is act as a screen now. It is act as a screen. Then image which is formed by our lens is formed on the retina. Then this is the object distance, right? The distance between lens to this image is called as image distance. No, then this 2.5, this distance is constant. Image distance is constant, but object distance is also constant. No, we can see the far objects, closer objects. We can see the objects clearly from 25 centimeters to at infinity. We can see the stars also, right? We can see the stars also. Then we have a far distance is infinity distance from objects which are present from infinity distance to 25 centimeters to 25 centimeters means least distance of distinct vision. Up to there we can able to see the objects. Okay, right? Then here, sir, u is constant. Sorry, v is constant. U will change. You will change or not? Sometimes I will see the closer objects. Sometimes I will see the far objects. Then u will changes. Right here in this case, u changes. Obviously. Then what's about focal length? Right? The principle 1 by f equal to 1 by v minus 1 by u. It is the principle, lens formula. We discussed lens formula. Right? Here, I think we already discussed a lab activity to finding the nature of the image and object distance and image distance. There we have observed, we have a table in that we entered that object distance and image distance, object distance and image distance. While calculating that, we got a constant value f of a given lens. Right? We got it. Have you noticed it? Then we have taken then object distance, image distance and focal length. For example, object distance is 20, image distance is 20. Then we have find out it here. Focal length and as 10. Okay. Such that in all cases, when I have taken 30, then this is approximately 15, then also I got 10. Then in such cases, f is constant. When u is changed, v is changed. Here which is constant? V is constant. Obviously, u is changed. We came to know that. We know that u is obviously changes. Object distance is obviously changes. V is constant. That means f will also changes. Right? The focal length of a lens is changes. Got data. Right. Then focal length of a lens is depends on material. Right? Focal length of a lens is depends on material which is used. Right? Then here it never changes the material. Okay. Right. Then one more chance. If the radius, if its radius is changes, if it is lens radius is changes, focal length will change. Got it? Radius is changes, focal length is change. Okay. Then how it can able to changes its radius? How it can able to change its radius? How it is can able to change means it has the lens is holds with an muscles that is called as ciliary muscle. What muscle? Ciliary muscle. So ciliary muscle is the responsible to change the focal length of a lens. Right? Ciliary muscle takes the responsibility to change the focal length of a lens. How it is changes, sir? How it is changes means, then for example, if object is far, if object is in far distances at infinity, object is at infinity, in such cases, then ciliary muscle is relaxed, and in such case the focal length of a lens is maximum. Can you see? Then for example, this is the shape of the lens at normal conditions. When we see the far objects, then the ciliary muscle is pulsed. See here, this is ciliary muscle is attached to our lens. Okay, then in this case, right, it is attached. If our eye is focused on far objects, then the ciliary muscle pulls the lens in these directions. In these directions, the ciliary muscle can pulse it. In such case, the shape of the lens becomes thin. In which case, when we observe the far objects, it can be at far objects. Okay, if object is at infinity, got it? Actually, then this is the shape of the lens. Imagine that this is the shape of our lens, right? If we focus on far objects, ciliary muscle is pulsed outward, and when it is pulsed, then the lens becomes thinner one. See, now it is diameter, then now it becomes thinner one. In such case, in these conditions, that means when we observe the far objects, in such cases, f is maximum. Focal length of eye lens is maximum when we focus on far objects, right? Here we know that u equal to infinity, object is at infinity distance, and v is 2.5 centimeters. F becomes maximum. Maximum means how much? That we are going to find. Which principle we have to use? Lens formula, 1 by f equal to 1 by v minus 1 by u. And here, while using this lens formula, we have to follow the sign convention. We came to know that this is a biconvex lens. Biconvex lens, object distance is negative, image distance is positive. How can you say, sir? Positive. With a biconvex lens, may image distance is negative also, no? Right? But here, what I said, the image of eye lens is formed on retina. That means, what type of image is given by retina? Our eye lens. Our eye lens can give the real and inverted and diminished image. Right? Very important question is this. Right? You may get in a polytechnic examination, some other competitive examinations they will ask. Then what kind of image, what is the nature of the image formed by eye lens? That is real, inverted and diminished. Got it? Right. Here I said real image, no. That's why it becomes positive. Got it? Right. Then here 1 by f equal to 1 by v equal to 2.5 minus u equal to 1 by minus infinity, minus of minus infinity, right? 1 by f equal to 1 by 2.5, minus into minus becomes plus infinity, and 1 by f equal to 1 by 2.5. Why? Because 1 by infinity equal to 0. Therefore, f maximum equal to 2.5 centimeters. Got it? If our eye is focused on far objects, if our eye is focused on far objects, our focal length is maximum, that is equal to 2.5 centimeters. Got it? When this is at far, then shape also changed. See, the lens is pulsed. Got it? And sir, always the objects will not be in a far distance, no? Sometimes the object is very closer. When we are reading the book, we will keep it closer. In such case, what is our focal length of our eye? In such case, how ciliary muscle changes the focal length? That means, right, it is far object. If object is closer, then it pushes the ciliary muscle, gets strained. Okay, the ciliary muscle can get strained and it pushes to decrease the size of the lens. Right? Then this is a normal condition. Now it becomes, okay, it becomes like this. Got it? Which can take that back? The ciliary muscle. Red color one shows what? Red marker is showing a ciliary muscle, and this blue color marker is shows the lens. Okay, right. Then in this case, what is the focal length? What is the focal length? Got it? Right. See here. Here again, object is closer. Closer means then when object is kept at least distance of distinct vision, I can able to see the object is clearly, no? Then here in this case, I will take U as 25 centimeters. 25 centimeters. Got it? Then V is constant, 2.5 centimeters. Then F minimum equal to, got it? Then which principle we have to use? Same, 1 by F equal to 1 by V minus 1 by U. Right? Here object distance becomes negative and image distance becomes positive. Okay, right. I will apply the values here. Then 1 by F equal to V equal to how much? 2.5. So 1 by 2.5 minus of minus 25. Okay, right. Then 1 by F equal to 1 by 2.5 plus 1 by 25. Then 1 by F equal to 10 by 25 plus 1 by 25. Okay, then here LCM is 1 by F equal to, LCM becomes 25, then 10 plus 1, right? Then 1 by F equal to 11 by 25, then F equal to 25 by 11, that means F equal to 2.27 centimeters. This is the minimum. Got it? This is the minimum focal length of eye lens. It can, this focal length, when object is closer. Got it? Right? Then simple. Then once again I will repeat simply. Here this is the normal position of the eye lens. You feel it? This is the normal position of the eye lens. When we focus at the far objects, the ciliary muscle can pulse it. Right? Then this is the normal position. When we focus it on the far objects, then while pulling, the lens becomes thinner one. Okay, right? And if we if our eye focused on closer objects, then ciliary muscle can pushes. It gets strained and pushed. Then this is feel it. This is a normal position. When it is filled, the size becomes like this. Got it? This is a normal condition. When we focused on far objects, it becomes thinner, and when we focus on a closer object, it becomes like this, right? This work can done by the ciliary muscle, right? Then here you noticed it, then focal length of eye lens is changing from 2.5 centimeters to 2.27 centimeters, right? It can able to adjust 2.5 centimeters to 2.27 centimeters, right? If a minimum focal length of eye will not be decreases than the 2.27 centimeters. Why? Because ciliary muscle can also can contract or expand for certain limit. Okay, because of that reason, when we keep the objects near, very closer to our eye, we can see the blur image. We discussed in our first class, when we keep the book closer to our eye, the letters which are printed in the textbook appears blur, because of our eye lens is not adjusting the focal length less than the 2.27 centimeters. Got it? We got the answer what we discussed in the first class. We discussed that. Then why the letters are appearing blur? Because of this reason, because of it has the eye lens has unable to change its minimum focal length less than 2.27 centimeters. Got it? Right. And here our eye lens can adjust its focal length from 2.5 centimeters to 2.2 centimeters, right? This ability of adjusting a focal length is called as accommodation of eye lens. What we call accommodation eye lens. Got it? Accommodation of eye lens means the ability of eye lens to adjusting its focal length is called as accommodation of eye lens. It can able to adjust from 2.5 centimeters to 2.5 centimeters to 2.27 centimeters, right? And you have to notice it. Then very important question. Okay, you will get main polytechnic question. What is our human eye's maximum focal length? 2.5 centimeters. What is the minimum focal length of eye? That is 2.27 centimeters. Got it? Then with the help of ciliary muscle, it can be happen. Got it? And then this image, the refracted light, our eye lens can give us forms the image on the one more transparent membrane protective, sorry, not transparent, sorry. Then one more delicate membrane is called as retina. This is called what? Retina, right? Then retina is consist of approximately 125 millions of receptors. What we have? What it contains? The retina consists approximately 125 millions of receptors, which are called rods and cones. Rods and cones, right? Then here, cones are sensitive to color. We can see the different colors in our day-to-day life. That where on what object we are focusing, then the light is reflected from the object is fall on our eye. When the light is fall on it, then the cones are sensitive for the colors. What are the colors present on the object? The total is sensitive by the cones only, right? If the retina is have absence of cones, right? If any person have no cones in retina, what happens? Retina can absorb colors. Then if there is no cones, then all objects can appear in black and white. Then finally his eye becomes a black and white TV. Black and white TV. Why? Because if have no cones, right? This is a function of cones. Cones can sensitive for colors. Okay, if absence of cones, the person can whatever any colorful, if you can give colorful flowers to him, all flowers can appear is black and white only. Okay, right. Then rods are sensitive for intensity of light. Intensity of light. Okay, then if the person in person's retina, if rods are absent, okay, if there is no rods in a retina, okay, in such case the person unable to find the difference between day and night. Was unable to find the difference between day and night if it has less amount of rods or it has no rods. Okay, such kind of defect is called as night blindness. We call what? Night blindness. Then he can't find any difference day and night. If he will sit in under the sunlight also, he can't find a proper sufficient of light. Okay, right. These are the work of the rods and cones. When light is reflected light falls on the screen, the rods and cones receives the light. They activated. When light is fall on the retina, rods and cones are activated, and that information, what we are observing, that information is transferred. It converts into the electrical impulse, right? The light can convert into the electrical impulse by these rods and cones, right? Electrical impulse means it is a script of rods and cones. What is our script? To communicate any two persons, we use either English or either Telugu. This is our script. But here, then rods and cones can convert the script into the electrical impulse, right? And retina is connected with millions of optic nerves. Okay, the optic nerves can collect that information and they passes to these are optic nerves. Okay, the information which are given in the electrical impulse, that electrical impulse are collected this optic nerves are collected the electrical impulse and they can pass to our brain, and finally the brain is processed the total information what we have seen. Ultimately brain is the important one. Okay, right. If brain is not functioned, our eye is functioned properly but brain is not functioned properly, then he can't find anything. Okay, right. This is the work of receptors. Got it? This is our structure of eye. Still we have some more important points parts present in our eye, but you will discuss that is in biological science. Okay, have get it? Then I consider cornea, outermost one, then aqueous humor and ciliary muscle, pupil, lens. Lens is a transparent material and flexible one. Here you have to notice one thing. Then what are the lens we are using in laboratory that can able to flexible? No, they are rigid. They never change their focal length. Okay, but this eye lens has the special property, and it never changes. It can able to change the focal length. Got it? Then with the help of the ciliary muscle, the eye lens can changes its focal length. The changing of focal length is called as accommodation of eye lens. Then maximum focal length is 2.5 centimeters and minimum focal length is 2.27 centimeters. And this image is formed on retina. Then our eye lens gives the real and inverted and diminished image. And the rods and cones are collected and they convert into the electrical impulse what we are seeing. That information is passed to the brain through the optical nerves. Okay, this is our today's class. Thank you.